Templates in C++ is one of the most confusing concepts. It's extremely powerful. It lets user do static polymorphism at compile time. But it's often one of the most misunderstood concepts. I've been reading the effective C++ by Scott Myers, and I found it to be very interesting. Today, we'll be talking about how template arguments are deduced. In my opinion, understanding the basics is very important and serves as the building block for advanced concepts. I'm Gautam and welcome to the first video on Practical C++. Let's get started. So let's start. Here I have three cases. There are three possible cases to define a template function. One is having a reference to t. One is having a universal reference to t. Now universal reference is not R value reference. It's a different concept. And the third case is having the value by copy, t, just the normal way. So let's look at the first example now. Let me uncomment this code. Okay, so let's say you have all these, you have value defined as 99, you have a copy to that value, const copy to that value, and a const ref to that value. Now, if you instantiate something with foo of value, what do you think will be the type t and the type of this input? And similarly, what do you think will be for copy value and ref to value? Now, this is how templates get a little bit tricky. So when you just pass value to foo, since value is the type of value is int, t will be int, and input type of input is equal to t reference. Okay, that makes sense. What about copy value? Copy value's type is constant. Okay, what will be the value of t here? So the value of t here will be const. Actually, t is equal to, let me do it like this, t is equal to const int, right? And type of input is equal to, so this will be constant now because copy value is of constant. Type of input will be const int reference. Now everything looks, everything looks the way it is, and I think most of the people watching this will be with me till now. Now things become to be a little bit interesting. So let's look at ref to value. Now ref to value is a constant ref. Okay, when we pass a const ref int to this foo function, what do you think will be the value of t and the value of input now? Value of t in this case, if you think it's constant ref, you are slightly wrong. And I don't blame you, it's part of C++ language, few nitpicky things of the language, but the type of t here is const int. So here's the rule that you can write. Whenever you pass a const ref or any reference, the type of t is deduced by removing that reference. So here you pass constant ref to this foo function, t will be just constant. We remove the reference, or the language removes the reference. But the type of input is still constant reference. So this is something that I didn't know, and it was really enlightening learning this. But yeah, it's one of those things that you only get to know when you have looked at it once. So I hope you learned something from it. Okay, that's just case one. Now comes the interesting part of case two. Okay, let me just copy paste this code here. All right, we have the same code here. Now Now let me just make some space. Oops. Okay. Now we have universal reference. As I said, it's not R value reference. It's a little bit different. Okay. Now what do you expect? You again pass value, copy value, ref to value. Okay. Now you pass int value for the first case. If you think t is still int, you will be wrong, because t is now a reference to int, and the type of input will also be reference to int. That is something that is a special case for R value, my bad, not R value reference, universal references. There are special cases for universal references because it treats a L value reference as it just adds a reference to an L value reference. So it's a little confusing. So let me say this, okay? Value here is a L value reference. So whenever your function has a universal reference, the template t parameter will be a L value reference, that is int ref here. It won't be int. Okay, let's see for the next case. Now the t, when you pass a const int, the t will again be a reference, but in this case it will be a const int reference, and type of input will again be constant reference. Okay, because it again copy value is L value reference, and for L value reference template t is deduced by adding a reference. And for the last case, it pretty much should be the same. So I'll just copy paste this. And for the last case, right? Let's say you do something like 437. What do you expect now? What do you expect? It's an interesting thing. So t now will be R value reference. Actually, I should write it like this: R value reference, and type of input. I'll just copy this. Type of input will also be R value reference. So, and type of input are basically mean this whole thing, tref. So this is how it becomes a little bit tricky, templates especially. Okay. So that was that. Now let's look at the third case. So let's look at case 3 now. I've just copy pasted some code, and here you can see that when we call foo of value, that is 99, t is int and the type of input is also int. So it's the most easiest case. There are no special rules. It's the usual way of solving things. All right. When we do copy value, the const int basically gets passed here. And so t, we think that t should be constant, but in actually it is not constant, because this t argument of input, this is a copy argument. It's not by reference, so it drops the const specifier. So here also int t is equal to int and type of input is still t. So the reason it drops the const specifier is a little bit confusing, but the best reasoning is that whatever happens in foo function happens to the copy of the t variable. So it doesn't really matter, like const at that point doesn't really matter. So that's why it gets dropped. Um, okay, for foo, here we go. For foo ref to value, we have this. Okay, what do we expect? Again, we will follow our first rule that we discussed. Whenever we have a const ref or ref for that case, ref always gets dropped in this t. So this t will always drop the ref. So this t will, let's say now, drops the ref and it has const int now. It has constant now, but we just discussed whenever we have t by copy, not by reference, we also drop the const. So here also t will be int and type of input will again be t. Okay. So this might be a little confusing if you look at first, but I can just repeat it once again. So the first rule was that whenever you have a reference that is passed to t, we drop the reference. Okay. So here you can see we passed constant reference here, and we drop the reference. We have constant. Okay. The second rule was that whenever we have a universal reference, okay, whenever universal reference, we either add a reference if it's a L value reference. For example, here value was L value reference, so we add a reference. If we don't have a L value reference, we have a R value reference, then we treat it as R value reference. Okay. And the third rule was that for function templates that have arguments by copy, we drop the const also. So here we drop the const also, and we get int. So these are few like rules for templates in C++, and this will be the building block when we talk about auto keyword in our next lecture. So I really hope you learned something from this lecture. I learned a lot while I was reading this chapter and in the book. So yeah, see you next time. See you next week actually in the next lecture. And please like and subscribe. It takes a lot of time understanding this stuff and trying to make the other person understand in the best way possible. So please like and subscribe so that I have some motivation to post these videos. So yeah, see you next time and have a good day everyone. Bye bye.